Thought today I showed you this type of proof of the triangle sum theorem. So let's look at a different proof of the triangle sum theorem. All right, I got my baby scissors. My baby scissors that my fingers won't fit into. What do you think? For the three interior angles of a triangle, is there some 180 or not? Agreed? So that's a different type of proof, isn't it? Do you think it's just as good a proof as this one? Maybe better, huh? Kind of different way to look at it, but if you were in ancient Greece, you would definitely look at something like this. For one reason, they didn't even have numbers the way we use them at all. They didn't use them the way we do. They would do anything, any kind of proof, they would show it that way. Anyway, I thought that was kind of interesting. We also talked about the exterior angles of a triangle, didn't we? Okay. And what did we decide about the exterior angles of a triangle? Their sum is 360. So if I just draw a triangle here and so that we can see the exterior angles. So you can see this one right here, and this one right here, and this one right here. Those three exterior angles, their sum is going to be 360 degrees. And I guess, could we cut them out? Could we do the same thing we just did and put them together and make a complete circle? Do you think they'd make a complete circle? Kind of hard to tell, I guess. Here, Miss Ecker, why don't you cut those out for us? So while she's doing that, let's talk about a new theorem. It's called the exterior angle theorem. Okay? So what we're going to do is I'm just going to draw a triangle here. And I'm going to show you this one exterior angle. You guys see that okay? Do I need to color it in with the marker so it's a little thicker? So one exterior angle. Doesn't matter which one I'm looking at, just one of them. Now let's think about our three interior angles. What was their sum again? Okay, so if we know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180, and we know that angle 3 and angle E, I'll call it the exterior angle, don't they form a linear pair? Aren't they supplementary? Okay, they are a linear pair. So they're supplementary. So I'm going to say the measure of angle 3 plus the measure of angle E is 180 degrees as well, isn't it? Okay, so we know, I mean, that's all linear pairs are supplementary, and if they're supplementary, of course, their sum is 180 degrees. So we know that these three add up to 180. We know that these two add up to 180. So, you got some angles cut out for us?
No.
Not quite yet. You're working on it, though. You'll have it in a minute. If we take, if we take the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, that must equal the measure of angle 3 plus the measure of angle E. Y'all follow along with that part? What did I just do? Is that substitution? Is that the transitive property? What do you guys think?
Probably substitution.
You think it's substitution?
Like off the transit.
I don't know if I could argue with it saying it's substitution. Could it be the transitive property?
Yeah.
They both equal 180, so do they equal each other? Okay, so we call that the transitive property. But I think we're okay getting there. And now, with a little subtraction property, let's subtract the measure of angle 3 from each side. And we end up with the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle E. E. Okay. This is the exterior angle theorem, and it says that every exterior angle of the triangle is equal to the sum of the two remote interior angles. I know, I saw all of your brows furrowed when I said that. That didn't make any sense to it. See the two angles on the interior of the triangle that are far away from this exterior angle? The two remote interior angles? Their sum thank you, is equal to the measure of angle E. So these two remote interior angles, okay? Now if I extend the triangle out this way, and I look at this exterior angle, we'll call it X, is that okay? Okay. So X, it's going to be the sum of the two remote interior angles. Which two angles are remote from angle X? Say it out loud. There you go, 2 and 3. And then I can extend this one out. We'll call this one angle Y. Angle Y is equal to the sum of what? Okay, so you guys get the idea? The sum of the two remote interior angles. And this is called the exterior angle theorem. We can look at any triangle. It doesn't matter how it's classified. It can be acute or obtuse or what else? What was the other one? Acute, obtuse, right, scalene, isosceles, whatever, okay? And this exterior angle is going to equal to the sum of these two interior angles right there. Okay? What's the deal with a right triangle? If this angle is a right angle, what do you think that tells me about angle 1 and angle 2? Say it out loud, don't just think it.
They add up.
Right. In a right triangle, the two acute angles, their sum is always what? Always 90. Okay, it's always 90. That's something we call a corollary to the triangle sum theorem. It's like, okay, you know the triangle sum theorem, how it says the three of them add up to 180? Well, this is a little, just add on it a little bit, a little addition to that theorem, okay? So if the three of them have to add up to 180, if one of them's 90, then the other two have to add up to 90 as well, don't they? So that's called the corollary to the triangle sum theorem. So we have the triangle sum theorem, three interior angles add up to 180. We have its corollary. In a right triangle, the two acute angles are 90. And P.S., in a right triangle, aren't the other two angles always acute? You couldn't have two right angles or another obtuse one, could you? You have to say, you can't just nod your head and think it in your head. You have to say it, guys. Okay, so that we got that one. Then we had the exterior angle theorem. So if I extend a line out and look at an exterior angle out here, it's going to be equal to this angle, angle 1, and this right angle added together. So that's the exterior angle theorem. And then we had all three of the exterior angles. So if we extend out and we look at all three of our exterior angles here, what is their sum going to be? Say it out loud. 360 degrees. And I think, did you cut those out for us? I'm going to have to put my glasses on to be able to see them. Oh, I flipped it over. And my thumbs are so fat I can't grab the dang things either. So you cut out our three angles of our exterior angles on our triangle. Look what a good job she did. What do you guys think? I can't get it to stay there. Keep sticking to my pen. Stay. Okay. So there's our three exterior angles. And is their sum going to be 360? All right. So that's what we learned today. So we had on this lesson we have two theorems and a corollary. We have the triangle sum theorem. The sum of the interior angles is 180. We have the exterior angle theorem, that the sum of the exterior angles is 360. And by the way, let me just say this, it doesn't matter if it's a triangle or a rectangle or a quadrilateral or a pentagon. It doesn't matter how many sides a polygon has, all of its exterior angles are going to add up to 360 degrees. Okay? And then we have the corollary to the triangle sum theorem that says in a right triangle, the two acute angles sum is 90. So here's what you're going to be asked to do today. You're going to be given a triangle like this, and they're going to tell you, well, this exterior angle is 5x subtract 10 degrees. This one right here. This one up here is 3x degrees, and this one down here is 40 degrees. So do you think that we can find the value of x and then find the measure of our missing angles? Say yes. All right. Okay. So we know that 40 plus what? 3x plus, you have to, hey, let's practice this. You have to, I'll ask it and then you all say it out loud. Ready? Plus what? Or wait, not plus anything. These two added together equal, what do they equal?
5x.
There we go. And we have an equation we can solve. So we can subtract 3x from both sides. We can add 10 to both sides. You follow? Right? We divide both sides by 2. And we get 25. So this one is 5 times 25. What is that? You can do it. You got 5 quarters. 125. Subtract 10. 115 degrees. This one is 3 times 25, 75 degrees. Okay, so 40 plus 75 equals to 115. You good? We did it, right? Okay. The other one would be, and this is funny that some people really struggle with this. This one's 2x degrees. This angle is x subtract 6 degrees. And then that one's like that. Can we find x? What do we know about 2x and x subtract 6? There you go, their sum's 90. We add them together. Are these parentheses necessary? So the first step in solving this equation is get rid of the parentheses, right? These parentheses aren't even necessary, so we can add the 2x and the x. We can add 6 to both sides of the equation. And then we can divide both sides by 3. Let's see, 3 goes into 9 3 times, and 3 goes into 6 twice. Okay, so 2 times. Make sure on these and on the test coming up someday, make sure that you read the instructions. It might ask you for the value of x, or it might ask you for the value of the actual angle. So you might have to come up and say, well, this is 2 times 32, 64 degrees right here. And this one is 32 subtract 6, so 26 degrees right there. Make sure we read the instructions about that stuff. Okay. Now I think you're all prepared to finish 5.1. But, good news, everyone. I completely left an entire page of the test out. But I made it for you today. Are you excited? Hold your hands. Woo! All right, here we go. I'll get it for you.